Before we plunge into the declaration, it's essential to comprehend what molecule gas petals are. The Large Hadron Collider LHC operated by CERN is a 17 ring of superconducting magnets and the world's largest and most powerful atom smasher. It represents the zenith of human scientific achievement. In fact, it's so powerful that it can reproduce the physical conditions of the universe's birth. But could this machine, designed to unlock the mysteries of the universe, hold the key to something far more grim? CERN, established in 1954, is one of the world's most prestigious research organizations with 23 member states and thousands of scientists. It serves as a hub for collaboration and innovation. The LHC is CERN's flagship project, but it's just one piece of a vast network of accelerators and experiments. Imagine a racetrack not for cars or horses but for subatomic particles racing through time and space. The LHC accelerates protons to nearly the speed of light, sending them on a collision course that mimics the energy of the universe at the moment of the Big Bang. These collisions generate temperatures more than 100,000 times hotter than the core of the sun. Thousands of magnets guide the protons on their journey, while intricate cooling systems keep the magnets at temperatures colder than space itself. The beams inside the LHC are designed to collide at 4 points around the accelerator ring, corresponding to the locations of 4 particle detectors at Atlas, CMS, Alice, and LHCb. Each serves a unique purpose, exploring different aspects of particle physics. Together they act as giant cameras capturing snapshots of these collisions. Scientists then sift through the debris, searching for signs of elusive particles like the Higgs boson, also known as the God particle, and other phenomena that offer clues to the universe's fundamental building blocks. By studying the microcosm, we gain insights into the microcosm. Yet with every answer comes another question, and with every discovery a new challenge. The LHC isn't just a scientific tool, it's a testament to human curiosity and innovation. It embodies our relentless pursuit of knowledge and our desire to understand the fundamental forces that shape our universe. But as we push the boundaries of what we know, we must also consider the ethical and existential questions that arise. What are the risks of probing the unknown? Could our quest for understanding accidentally unleash forces we cannot control? In the hallowed halls of CERN, where the limits of human understanding are constantly pushed, a discovery has emerged that sends a chill down the spine of even the most seasoned scientist. Brian Cox, a former scientist at CERN and a prominent voice in the world of particle physics, recently made a declaration that has left the world both intrigued and fearful. Cox's words resonate with haunting clarity. The goal of CERN's Large Hadron Collider is to create a mini Big Bang. Yes, you heard that right, a miniature version of the very event that gave birth to our universe. Cox further explained the implications of this goal, highlighting the LHC's extraordinary potential for groundbreaking discoveries. This includes its ability to unlock the secrets of the Higgs boson and explore dark matter, a mysterious substance that makes up a significant part of the universe. Imagine wielding the power of creation, the ability to summon the very essence of the universe. It's a tantalizing prospect, but one fraught with peril. The mini Big Bang isn't a theoretical concept, it's a tangible reality within the LHC. The temperatures, the pressures, the raw energy all replicate the conditions of the universe's inception. It's like standing at the dawn of existence itself. Yet with such power comes responsibility, and the question looms: what if something goes wrong? In fact, something did go wrong. Back in 1978, the Russian physicist Anatoly Bugorsky experienced a catastrophe that would forever alter the trajectory of his life. While working on the U-70 synchrotron at the Institute for High Energy Physics in Russia, a malfunction led to his head accidentally coming into the direct path of a proton beam. The beam, with a force that defies comprehension, passed through his skull, entering the back of his head and exiting through his nose. Bugorsky's experience was miraculous. He saw a flash brighter than 1,000 suns but felt no pain. The beam's path left a trail of destruction, burning through tissue and bone, yet he remained conscious and even walked to the clinic for treatment. The aftermath was both terrifying and fascinating. The beam caused localized tissue death, resulting in hearing loss in one ear and partial facial paralysis. Astonishingly, Bugorsky's intellectual abilities remained intact, and he continued his scientific career. This incident serves as both a personal tragedy and a cautionary tale, underscoring the immense power and potential danger of particle accelerators. The risks of an atom smasher like the LHC are not to be taken lightly. The potential for unforeseen reactions, the manipulation of the very fabric of reality. These are not the stuff of science fiction but real concerns voiced by some in the scientific community. One of the most alarming and captivating concerns is the possibility of creating a mini black hole. Black holes are regions of spacetime where gravity is so strong that not even light can escape. They are cosmic vacuum cleaners, devourers of stars, and enigmatic entities lurking in the shadows of our universe. That the LHC could create such an entity even on a minute scale is staggering to both the general public and experts alike. Could this black hole grow uncontrollably, consuming the Earth from within? Although CERN scientists assure that any black hole created would be unstable and dissipate instantly, the remote possibility has ignited debates, fears, and a sense of awe at the power we wield. It's crucial to understand how the LHC could create a black hole. It relates to the fundamental mechanics of particle accelerators. When protons collide at nearly the speed of light, the energy released is so immense that it bends the fabric of spacetime itself. Imagine a trampoline stretched tight with a heavy weight dropped onto it. The fabric bends and warps, and if the weight is heavy enough, it could create a depression so deep that anything nearby would be drawn into it. That's a metaphorical illustration of what could happen in the LHC. In the quantum realm, where the laws of the universe are both strange and beautiful, there exists a theory that extra dimensions may be hidden within our universe. If these dimensions exist, the LHC's collisions could tap into them, creating a gravitational funnel that forms a tiny black hole. This mysterious dance of particles has even captured the attention of renowned scientists like the late Stephen Hawking. In his work, he warned of a scenario where the Higgs boson could become unstable at extremely high energy levels. This instability could lead to a catastrophic vacuum decay, a cosmic event that would not only destroy the Earth but obliterate the entire universe. The respected British cosmologist and astrophysicist Sir Martin Rees has also expressed concerns about the experiments conducted at CERN. In his book on the future prospects for humanity, he explored the potential risks associated with particle collider experiments, including those at the LHC. His words were not merely cautionary but tinged with a sense of existential dread. Rees discussed a worst-case scenario where a catastrophic experiment could create a condition known as vacuum instability. This instability, in theory, could trigger a phase transition that would ripple through the fabric of spacetime itself, resulting in a universal catastrophe. Such a phase transition could fundamentally alter the constants of nature, rendering the universe unrecognizable or completely uninhabitable. While the likelihood of such an event is considered infinitesimally small, the sheer magnitude of its implications, should it occur, makes it a topic of serious philosophical and scientific debate. The questions raised extend far beyond physics. They touch on ethics, responsibility, and the limits of human ambition, balancing risk and discovery. For many scientists, the potential benefits of the LHC far outweigh the risks. The collider has already led to groundbreaking discoveries, including the confirmation of the Higgs boson in 2012, a milestone that deepened our understanding of how particles acquire mass. Additionally, the LHC continues to probe the mysteries of dark matter, dark energy, and the nature of the universe's expansion. These investigations could eventually help us answer some of the most profound questions in science. Why does the universe exist? What is it made of? How will it end? Yet, as the LHC continues to operate, skeptics urge caution. Critics argue that the pursuit of knowledge should not come at the expense of existential risks, no matter how improbable they may seem. They call for more transparent risk assessments and ethical oversight, ensuring that humanity's quest for understanding does not inadvertently lead to its undoing. CERN's assurances. CERN officials have repeatedly addressed public fears, emphasizing that their experiments are conducted with the utmost care and safety. According to their statements, the LHC operates within the boundaries of known physics, and any phenomena created, such as micro black holes or exotic particles, would pose no threat to The Earth, these entities, they explain, would decay almost instantly in accordance with well-established scientific principles. Furthermore, natural high-energy particle collisions occur constantly in the universe, such as those caused by cosmic rays striking Earth's atmosphere. If such collisions had the potential to trigger catastrophic events, they would have already done so over the billions of years of Earth's existence. Philosophical implications. The debates surrounding the LHC are not purely scientific, they are deeply philosophical. The collider represents the pinnacle of human ingenuity, a symbol of our insatiable curiosity and drive to uncover the universe's secrets, but it also forces us to confront fundamental questions about our place in the cosmos and the potential consequences of our actions. Should we continue pushing the boundaries of what is possible, even if it means flirting with unknown risks? Or should we exercise greater caution, mindful of the delicate balance that sustains life on Earth as we stand on the precipice of discovery? The LHC serves as a powerful reminder of the duality of human progress, the capacity for both creation and destruction. It challenges us to navigate this duality responsibly, ensuring that our pursuit of knowledge uplifts rather than imperils the world we inhabit. Restricted to hypothetical insights, he relegated a likelihood to these disastrous results, yet a low one. However, even a microscopic change, he contended, ought to provide us with an opportunity to stop and think. The stakes are unfathomably high and the edge for blunder is razor slight. The researchers at CERN have determined the probabilities, run the simulations, and examined the hypotheses to argue for the safety of the LHC. In fact, Brian Cox himself acknowledged the importance of responsible analysis, recognizing the widespread fears and concerns surrounding the activities of the LHC. He emphasized that rigorous safety measures are in place along with extensive reviews and protocols ensuring the LHC's operations are conducted with meticulous care. Cox reassured that the energies involved are well within what the Earth naturally experiences and that the chances of creating a stable black hole are astronomically low. Even if one were created, scientists say it would be so minuscule and unstable that it would vanish instantly in a burst of energy, a phenomenon predicted by Stephen Hawking, known as Hawking radiation. It would be a fleeting moment of immense insight, a brief look into the abyss and then gone. Some have gone further, speculating that the LHC's experiments could open a portal to another universe or dimension. This idea, though largely dismissed by mainstream science, has captured the imagination of many and has become a subject of interest, fear, and even folklore. What lies beyond our world? Might we accidentally unleash forces or entities we do not understand? The notion of opening a portal to hell has even been dramatized in various media, fanning the flames of uncertainty. But how did this idea arise, and what does it mean in the context of scientific exploration? The concept of parallel dimensions isn't new in physics. String theory, a leading contender for a unified theory of everything, posits that there may be more than the familiar three dimensions of space and one of time. These extra dimensions could be compactified or hidden from our perception, but they might theoretically be accessed or revealed under extreme conditions. Now, imagine the LHC as a cosmic key, unlocking doors that have been sealed since the beginning of time. When protons collide at energies never before achieved on Earth, they could, in theory, create tears in the fabric of spacetime, potentially exposing hidden dimensions. While mainstream science remains skeptical of such dramatic claims, the mere idea of particle accelerators uncovering the universe's secrets has fueled broader public interest in the potential risks and consequences of such experiments. Ultimately, the LHC stands as a powerful symbol of human curiosity and ambition. It is a testament to the progress we've made in understanding the universe, but also a reminder of the dangers that come with such knowledge. The universe may be vast, but the more we uncover about it, the more we realize how little we truly understand. The quest for knowledge is one of humanity's greatest achievements, but it is also fraught with uncertainty and risk. Time will tell if we are ready for what we might uncover. Next, the Large Hadron Collider. LHC is a marvel of modern science and technology, but it also raises questions that challenge the very foundation of our understanding of the universe. The machine itself is an engineering masterpiece stretching across a massive underground ring and featuring the most advanced and precise equipment ever built. It brings together a global network of scientists and engineers, united by one goal: to answer some of the most profound questions about the universe. However, as scientists push the boundaries of human knowledge, they also face significant challenges, both theoretical and ethical. One of the key areas of study at the LHC is the quest to understand the forces that govern the universe. For decades, scientists have sought to unlock the mysteries of gravity, electromagnetism, and the strong and weak nuclear forces. The LHC provides a unique opportunity to study these forces under extreme conditions. The collision of particles at such high energies replicates conditions that existed mere moments after the Big Bang, when the universe was a hot, dense soup of particles. This allows researchers to probe the behavior of matter and energy in ways once thought impossible, yet with the potential for groundbreaking discoveries. The LHC also raises significant questions about the limits of scientific experimentation. The possibility of discovering new particles, such as supersymmetric particles or dark matter, could revolutionize our understanding of the universe. However, these discoveries could also have unforeseen consequences. There is a growing awareness among some physicists that the experiments conducted at the LHC may be uncovering more than just the secrets of the universe. They may be revealing new dangers or forces that humanity is not yet equipped to handle. One of the most intriguing and unsettling ideas in this regard is the concept of vacuum decay. This theory suggests that under certain conditions, the energy generated by particle collisions at the LHC could trigger a catastrophic change in the fabric of spacetime, setting off a chain reaction that could alter the very nature of reality itself. While the likelihood of this happening is extremely low, the potential consequences are so severe that some argue the risk should be carefully considered. A vacuum decay event, if it were to occur, could cause the collapse of the universe as we know it, potentially leading to the destruction of all matter and energy within our cosmos. Despite the speculative nature of these concerns, the LHC remains a focal point for scientific inquiry. The excitement surrounding the possibility of new discoveries often outweighs the cautionary voices. Every day, thousands of scientists work tirelessly at CERN, driven by a deep desire to uncover the fundamental truths that govern existence. Yet, as the LHC operates at the cutting edge of science, the ethical implications of such powerful experiments remain a topic of ongoing debate. Another area of concern is the potential for creating phenomena that we simply do not understand. The LHC has already demonstrated the ability to create exotic particles such as the Higgs boson, which were previously only theorized. However, this ability to create new forms of matter also raises the question of whether we might inadvertently create particles or substances that pose unforeseen risks. In a sense, the LHC is like a laboratory where nature's most powerful forces are unleashed in a controlled environment. But nature, as scientists have learned time and again, is not always predictable. The potential for creating new forms of matter or energy extends beyond the LHC. Advances in technology and our understanding of quantum mechanics may one day allow for the creation of entirely new materials or forms of energy. While this holds great promise, it also brings with it the possibility of catastrophic failure. New technologies, while offering tremendous benefits, have the potential to disrupt the delicate balance of nature and create unintended consequences. Ultimately, the quest for knowledge is driven by humanity's insatiable curiosity and desire to understand the universe. The LHC represents a monumental leap forward in our understanding of particle physics, but it also highlights the complex and unpredictable nature of scientific progress.